This video will have the solutions to quiz 4.3. If we have the absolute value here equal to 9, this will work out if the insides are equal to either 9 or minus 9, because the absolute value will make the minus sign go away. So that means I can solve this problem by setting up two different equations. Either 2x minus 1 equals 9, or 2x minus 1 equals minus 9. And then I go ahead and solve those separately, and I'll have my two answers. First one, we add 1 to both sides. 2x equals 10. Divide by 2, and we get x is 5. On the other side, follow the same process. Add 1. 2x is minus 8. Divide by 2. X is minus 4. So those are our two solutions, and we would show it as x equals minus 4, comma 5. For number 2, we have another absolute value, but now we have an inequality. The absolute value of x take away 3 is greater than or equal to 4. And remember the saying that when you have greater than or more is or. Alright, so you're going to use an or setup, and you're going to get one of those split graphs like that. Alright, so the way we're going to set that up is we're going to do x take away 3 greater than or equal to 4. So we're going to keep the symbol in the same direction and keep the sign of the number, or the insides again, x minus 3, switch the symbol, less than or equal to, switch the sign. And be careful not to switch the sign of the insides of the absolute value. Keep that the same as it was. But what we're doing here is keep the sign and keep the direction, and then switch the sign, switch the direction. So let's go ahead and solve it out. So we solve the two inequalities separately now. So let's see, we're going to add 3 to both sides. X is greater than or equal to 7. Or, on the other one, add 3 to both sides. X is less than or equal to minus 1. So let's see what that looks like on a graph. So if we graph this out, we have the important points are minus 1 and 7, and we're greater than or equal to 7, and because it can be equal to 7, we're going to put the bracket there. Greater than means going to the right. And then for the x is less than or equal to minus 1, again a bracket because it can be equal to minus 1, and then we're going to the left. So that would be the graph. And for interval notation, it's easiest to go right from the graph. So what we want to do is think about the endpoints. We have a negative infinity endpoint because we're never stopping going to the left. Way to the right we have a positive infinity endpoint. And for interval notation, copy everything down in exactly the order it shows up on the graph. Minus infinity, parentheses because we never reach it, to minus 1, bracket, or 7 to infinity, another parentheses around the infinity, and that would be the interval notation answer. And the third one is another inequality, but now we have a less than instead of a greater than. Alright, for the greater thans we do more is or. For the less thans we do less is nest. So in other words, you're going to get a nested and kind of a result. So what we're going to do is take the insides out, x plus 7, keep the less than 10, and we're going to nest it within a greater than minus 10. And then we go ahead and solve the three-part inequality. Take away 7, take away 7, take away 7, minus 17, x, and 3. So x is greater than minus 17, less than 3. And let's take a look at the graph. And you'll see how it comes out to be this kind of a shape right up here. So we put down our important points, minus 17 and 3. And we want to be x is greater than minus 17, but less than 3. So we're right in between the two numbers. Parentheses on both of them because we're not including them as possible values of x. Interval notation, again, go right from what you see on the graph. We only have two endpoints here, minus 17 and 3. We're not going to infinity on either direction. So we're going to put down the endpoints that we see with parentheses, and that's our final answer.